Right. Okay. Hello. So in this video, we will look at mathematical skills that you need to know before you write your final exams. So this is a must-have skills. In fact, I'll make a series, I think 3 videos on mathematical skills. So this is the first one. This one, exercise one, should a little bit be easy for you to do. So I'll ask you as usual, please, you can pause the video now and attempt to answer all these questions by yourself before continuing with the video and look at my solutions. So please pause the video, attempt all of these problems by yourself, and then come back and view the solutions. So all you have to do here is to solve for the variable that has a question mark. For example, in 1.1, delta x is v delta t, so you just solve for delta t. And for 1.2, a is v final minus v initial over time, delta t, and then you just solve for v final. And 1.3, f net is ms times v final minus v initial over delta t, and then you solve for v initial, and so on and so on and so forth. So please pause the video and attempt these problems by yourself, and then when you are done, you can come back and view my solutions. All right, so now is the time to pause, and then let me get to it. Right, let me do this, and let me select a pen, and then let's go for it. Just check that for 1.1, I think it should be easy for you. Delta x is v delta t, implies that we're just gonna have to divide by v here. So delta t is delta x over v. Okay, good. Now let's go to 1.2. I can maybe give you a mark. You can mark yourself if you want. I think this should be 1 mark, like that, right? So that you can do by yourself. So let's go to 1.2. A is equal to v final minus v initial over delta t, and then we want v initial. So then this implies, then the first thing that you do if you want this v initial, we're just going to have to multiply by delta t both sides, and then I'm going to write this expression on the left hand side. So I'll do that simultaneously, so please be comfortable with this. V initial minus v final is equal to a delta t. Okay, then that implies then that you want we want v final, so then v final, additive inverse of minus v initial is positive v initial, so then I will have positive v initial here plus a delta t. Okay, and then of course you can also mark yourself. I think you can mark yourself here, and then for your final answer there. Okay, and then let's go to 1.3. 1.3, there we go. 1.3, f net is equal to mass into v final minus v initial over delta t, and we're asked to solve for v initial, so we'll do the same thing, and then again be comfortable with this procedure. V final minus v initial is equal to f delta t, and then what we want v initial, So then we divide by mass. So V final is equal to F delta T divided by mass. Sorry, let me just erase that. So V final minus V initial is F delta T divided by mass. Then V initial. So then I have minus V initial is equal to F delta T over mass minus V final, which means that V initial is equal to V final minus F delta T divided by mass. Okay, so that's another mark. How do we mark this? We're just going to, I don't know, give you a mark there, then give you a mark cell for the final answer there. Okay. Please allow me to make some comments about this result here. I'm just going to make some extra comments here. Okay, that's a red pen, which is not what we want. So note that so if you want to see if this answer is reasonable, note that if you've done momentum already, this is saying that V initial, the initial velocity, is the final velocity minus, note that F delta T is equal to change in momentum, okay? Change in momentum divided by mass, okay? So this is saying that V initial, starting velocity, is the final velocity minus mass change in velocity. Let me erase this again here. Let me just do that. Sorry, I need space. Okay, so this is saying that V initial is V final minus the, I'll do this here. So that's your, let's put the M here. So this is, then this is M delta V over M. And so then the initial velocity is the final velocity minus the change of in velocity, and that's reasonable. Okay, so if you have a final velocity minus the amount it changed by, and that gives you just the initial velocity, so you can make sense of your results in that way. Anyway, so let's go to 1.4. Okay, V final squared is V initial squared plus 2a delta x, and then we want to solve for delta x. So let's do that. 1.4 not the red pen again, please, the black pen. 1.4, what we want is to solve for delta x, right? So what we have is V final squared is V initial squared plus 2a delta x. Okay, so we want to solve for delta x. Again, please be comfortable to write this on the right hand side. Is equivalent to V final squared minus V initial squared. Okay, then that implies then that your delta x is V final squared minus V initial squared divided by 2 times acceleration. Okay, so that is how we do this one, and then you can give yourself a mark. That one there, 2 marks. Let's look at 1.5. We want to solve for delta t, right? So for 1.5, we want to solve for delta t. How do we do that? Let's start with the equation. It says delta y is v initial delta t plus half acceleration delta t squared. Before I proceed, I want to make my variables a little bit simple when I manipulate. Don't want to be writing the deltas. So I'll let delta y just be y, and delta t be what? Bt. So then I have y is equal to v initial t plus half a t squared. Okay, so then I want to solve for t. Note that I have t squared here and then I have t here as well. So then this is quadratic. So then I proceed by half a t squared plus v initial t minus y is equal to 0. Okay. Then assume that the acceleration is not 0. So a is not 0. So then what we can do is multiply by 2 everywhere and divide by a. So I will so let's multiply by 2 over a. What do we get? We get t squared plus 2 over a v initial t minus 2 over a y equals 0. Okay, then you do this as you would solve for the for x when you're doing quadratic equations. So we will have our a is 1, b is equal to 2 over a v initial, and c is equal to minus 2 over a y. So this is from this form of ax squared plus bx plus c. So that is the general form of a quadratic formula. So then what do we have? We have t is equal to plus minus b. Sorry, that's not the case. It's minus b, which is 2 over a v initial plus minus the square root of b squared, and b squared is going to be 4 over a squared v initial squared, b squared minus 4, then our a is 1 times c, so 4 times minus 2 over a y, so that's 4 times 1 times c, which is minus 2 over a y, divided by 2a, which is 2 times 1 is 2, right? So then what do we get? This is equivalent to minus 2 over a v initial plus minus the square root of b squared 4 over a squared v initial squared, and then minus times minus is a positive, plus 8 8. I'm just going to put 8y over a, all divided by what? By 2. Okay, so that is our t. Okay, right, so let's look at this expression a bit, and then we observe that we can maybe go further and simplify it a bit. Let's see how we can simplify it further. We can separate the denominator. So this term, we can give it this denominator, and then this term we can give it also this denominator. So we can go further here. So let's do that. Let's do that. Let's do that. So we can have t. So there's two solutions, obviously, t1 and t2. I'm just going to write t. So that is equal to minus 2 over a v initial, say all divided by what? By 2. And then plus minus the square root of 4 over a squared v initial squared plus 8y over a divided by 2 as well. Okay, so then this gives us so these 2 and these 2, they cancel out, so you have minus v initial over a, okay, plus minus square root of and then what you can do here is that you can take the 2 inside the square root, so that's going to become 4. All right, so that's a trick. So basically, if I have a square root of a over 2, that's the same as the square root of a over 4, basically, since you can since by the rules you just say square root a over square root 4, which gives you the square root a over 2. So that's what we can do here as well. So I can have 4 v initial squared over a squared, and then I can take the 4 inside, plus 8 over 4 y over a. Okay, so that gives us t is equivalent to minus v initial, no, not squared, just minus v initial over a plus minus the square root of so this 4 and this 4 cancels out. We have v initial squared over a squared plus you can see that the 8 over 4 becomes 2 plus 2 times y over a. Okay. Okay, and then we can just verify that at least this is dimensionally correct. Let's look at this term here, v over a. The units of velocity is meters per second, and this is meters per square second. So the meter and the meter cancels out, and then you have second minus 1 plus second 2. So this will be in seconds. And then let's look inside here. First, you must note that there's addition here. So let's make sure that we are adding the same dimensions. We're not adding apples and oranges. So let's look at this first term here. Meters per second, and then you square that, you have meter squared per second squared. And then here you also have meter squared per second to the minus 4. So if you do the division, then you will have square seconds for the first term. And then the second term is meters divided by meters per square second. So the meter and the meter cancels. And also here you have square seconds. So then this addition makes sense. And of course, the square root of a square second is seconds. So this looks reasonable. Okay, so let's move on to the next following question. Let's solve for r. So you have f is equal to g, mass 1 times mass 2 over r squared. Solve for r. So let's do that. That is question number 1.6. Let's do 1.6. 1.6. F is equal to G m1 m2 over R squared. That implies that R squared F is equivalent to G m1. Okay, let me just erase this. G m1 m2. Okay, so then that means that R is equivalent to, so you divide by F, all right, and then you take the square root, positive root, since R is distance, so it should be positive. And so that's how we do 1.6. And then 1.7, we're supposed to, this is a photoelectric field, photoelectric effect equation. So HF is HF 0 plus half mv squared, and then we're asked to solve for V maximum. So the equation is HF is HF naught plus half mass V max squared, the equation you will see in photoelectric effect. So as usual, we will have our variable on the left hand side. So that gives us, note how I do this, right, is that if you subtract HF naught on both sides, you'll have HF minus HF naught, and then you'll have half mv squared on the right hand side. But then I can write what's on the right hand side on the left hand side, and then copy what's on the left hand side on the right hand side. So that is HF minus HF naught. And then we multiply by 2 and divide by m to remove the coefficient in front of Vmax. So then we have Vmax squared equivalent to, I'm just going to have H here, F minus F naught. So then I have multiplied by 2 and then divide by the mass m, all right? And then we take the square root. The Vmax is the speed, so we're just gonna take the positive root here as well. Is 2h into F minus F naught divided by the mass m. Okay, so that is our Vmax. All right, and then 1.8, last one in this activity, 1.8 is that we must calculate the escape velocity. So the information here, this is extra info, that the escape speed, which is the minimum speed required for a body to escape the gravitational pull of the planet. So this speed gives you the launch speed. So if you give an object this speed, which is called v escape, then it will be able to escape the planet. All right, so that is called the escape speed or the escape velocity. And so that happens when the difference between kinetic energy and potential energy is 0. So then let's solve for v escape. So the equation for 1.8 is that we have half mass v escape, right, v squared minus g mass m over r is equal to 0, and this small m is the mass of an object, and this is the same mass here, and then the big M is the mass of the planet. Okay, so then immediately we can first divide by m, and then multiply by 2. So we'll have v escape squared minus So we multiply it by 2 gm big M, and then the small m cancels out. Maybe let me write it actually, RMM, then that cancels out. So you have V escape squared is equal, it's equal to, this is 0, so I'll check this on the right hand side. So that's equal to 2 G big M over R. Okay, and then we just take the square root. So then V escape speed is the square root of this term here, 2G M big M divided by R. Okay, so that's how you so this activity was just give you the skills that you need before you write your final exams. So you need to be able to manipulate the physics equations and solve for various variables. So now we will continue this tutorial with the second set of the problems. So this is type 1, and then in the next video I will do the other types of problems, right? Yeah, thanks for listening. I hope that you've enjoyed this activity. Of course, if you want to give yourself marks, you can do that, right? 1, and then maybe 2 there, and also we can mark this as well. So you've written this in the standard form, so that can give you a mark for that. And then the quadratic formula, that's mark, and then the substitution, that's another mark. And then you simplified, that's another mark there for simplification. And then this is your final answer there. Okay, all right, thank you. Okay, maybe let me, yeah, all right, thanks. I'll see you in the next video.